Bam. Now you can hear it eventually, whenever it gets caught up to the thing. Okay. Algebra bought 24 fireworks for 50 bucks. 24 fireworks. $50. Great. Two totals again. Whoa. One costs $1 and the other costs $3. Set up and solve a system to determine the number of each firework purchased. So how should we do that? We need equations first. I love the idea of doing elimination. That's a great idea. But we need to write a couple of equations first. How many total fireworks did they buy? 24. So how about x plus y equals 24? Right? That's easy money, right? What would the other equation be? So, not quite. How much did one of them cost and how much did the other one cost? $1 fireworks and $3 fireworks. So, $1 fireworks plus $3 fireworks equals $50. Right? Now we can solve that. So what should we do to solve it? Gavin suggested elimination, which sounds great. What are we going to have to do elimination? Get one of the x's to be negative. That's true. So how are we going to do that? Thank you. Did you finish it? As best as it's going to be? Oh, my, 15. What'd you say?
Multiply by -1.
Multiply this one by -1. Sounds like a great idea. So that turns into negative x minus y equals negative 24. Now we eliminate. The x's poof away. 3y minus y is what? 2y. That was a mistake I saw on some things. I don't remember whether it was this paper or the Algebra 2 thing that I was grading, but something along those lines. Great. 50 minus 24 is what? 26. Who'd have thunk it? Divide it by 2, divided by 2, and y equals 13. So there were 13 $3 fireworks. 13 $3 fireworks. Great. So now what? Substitution. Sounds great. We're going to sub 13 into where? Sounds great. I'm going to sub it in right here. Into the y on this one, right? That's going to be easiest. You could solve it right, put it right here, but it'd be easier up here. So then x plus 13 equals 24. Subtract the 13, and we end up with x equals 11. So there were 11 $1 fireworks. Great. Easy peasy lemon squeezy. Huh?
Would it have been better just like not answer it and answer it and get it wrong? Like just leave it blank.
No, it would not have been better to leave it blank. It would definitely not be. You would lose all the points and you would not have engaged with the material at all. Because, I mean, yours is kind of a mess, so it may be hard to figure out. But what you can do when you miss it, if you have something on the paper, then you can go back and be like, okay, where was I thinking wrong? And that way, then your thinking gets to improve and you actually get to learn and it becomes actually useful, right? But if you left it blank, then, you know, who the heck knows what you were thinking? You've slept a few days since then, right? So yeah, it's definitely better to put something, even if you get it wrong. Well, that could be part of the problem. Let's do today's lesson.
Wait, so can I use this as the corrections, the thing we just did?
Yeah, that can be part of the corrections. Yeah, absolutely. So we're going to do, as y'all might have guessed, we're going to do the lesson today in class. which means your homework assignment will be given today during class. So there will be, I'm saying this now, and I will say it later. You need to make sure you write your homework or problems down today in class. Because if you don't do that, then you won't know what the homework is, and you'll be asking me. I'll be like, go back and watch the video, and you'll be like, oh, dang it, right? So don't do that. Sound all reasonable and great. Oh, speaking of oh, dang it, I didn't think about the fact that I need volume 2. I need to go grab a different book. Give me a second. I think I can teach this lesson blindfolded, but whatever. Yeah, we are on Unit 7. 7-1, that's true. Unit 7, Lesson Numero Uno. Wow, perfect. You have what?
No paper.
I see paper right there.
Well, that's graph paper.
That's true. It's tier. You have to use graph paper. So sad.
So we're doing like 7-1 notes?
We are doing 7-1 notes, and if there ends up being a spot to turn in those notes, you'll turn in what we did in class. Make sense? Easy peasy, lemon squeezy, no problemo. What? After class, you need to tell me something? Oh, okay. We haven't even learned it. Oh, you've like from the test? I don't understand.
Google Classroom.
Okay. Duplication.
Yay.
Properties of exponents. Oh no. Okay. On the board, there are some things. Which one or ones of these things is a monomial? This is where you guess. This is where you guess. This is where you don't know, but you guess. As which one or ones of these is a monomial?
Number, a variable, product.
No cheating. Stop cheating. And aside from that doesn't really answer the question, because that doesn't tell me which ones of these you think is a monomial.
3x squared.
I think it's that one.
You think it's this one?
I don't know, do I?
12x.
I don't know. That's the one I was talking about. Is that the one you're talking about?
Yeah.
No, that's wrong. That's not a monomial. That's in fact a trinomial, actually.
We're going to say 12x
minus 4.
Oh,
This one is a monomial. It has a single term. That's a monomial right there. That's true. Now, there's some other type of thing up on the board. Which one or ones of these is a constant?
6x minus 4.
5?
Oh.
5 is a constant. That's true. And negative 36 is a constant. Those are both constants. So what's the difference between a monomial and a constant?
Yeah.
Yeah.
That is multiplied by an x. So
Yeah.
it needs to be. It's
So-
not constant because
Multiplied by a
it can change.
variable?
Multiplied by a variable, it's not constant because it can change. All that's true. Sorry, I was texting.
It wasn't very smart.
It was quite smart. It was Simple, but smart. Here's another monomial. That's a monomial. Why is that not a monomial?
Because it's got constant animal.
Because it's got more than one term in it, right? This would be a binomial. This one would be a trinomial. But we'll talk about those later. But these are monomials. These are constants. It's time for Be Real. Oh no. Take a selfie. Mom better do it, huh? Because Gavin's not there to do the Be Real. Oh no, the elder clan is going to be late. Oh no. Here you go. You can be in my Be Real. Well, you mostly look like a tripod, so you know. Okay. So, that's a bit of vocabulary, right? Easy money. Now, we're going to learn several different properties in this unit. And by several, I mean about 5.
I think that's valid, because a couple is only like 2 or 3. So several should be like 4 or 5.
Yes, that makes sense. No. See, you said something that's a straight up lie, and it's like a lowercase p pet peeve. A couple is 2, period. A couple is 2 and only 2. The word couple means 2. So when people say a couple and they're like, I want 3, that drives me crazy. A couple is 2, period. A few can be 3.
That's fair.
Right?
Okay, my bad.
Anyway,
My bad.
The random things that set people.
here's our first property. This is when like bases are multiplied. X to the A times x to the B. Right? So see, this is like bases. They're multiplied. They've got different exponents. If you have like bases multiplied, you add the exponent. So this would be x to the A plus B. Okay? The second property is if we have a power to a power. So if we have x to the A to the B, right? So we've got it raised to a power and then raised to another power. You multiply those exponents. So this would turn into x to the A times B. Easy peasy. It does make sense. It's no problemo. What? You probably have done this before. We probably did this in pre-algebra. Nerd. No, just kidding. Let's do some examples.
Okay.
Example. Simplify. Z to the 3, Z to the 5th. Z cubed times Z to the 5th. So what would we do? Yeah, how? Which one of these two are we doing in this problem? No, that's not Z cubed to the 5th. Yeah, this is Z to the something times Z to the something. So what are we going to do with those exponents? Add them. So this would equal Z to the 8th. Let's do another example. A squared, B to the 5th, A cubed, B to the 3.
Is it 2 like bases multiplied, like together?
Yeah.
Should be like.
So we could, to make it clearer, we don't necessarily always have to do this. To make it clear, we can use commutative property and move this stuff around, right? And turn this into a squared times a cubed times b to the fifth times b cubed, right? So we've got like bases multiplied. What do we do with the exponents? Add them. So this would turn into a to the fifth, b to the eighth. Simple stuff right there. No big dealio. Let's do another example. Jim has got this. Negative 8x to the fifth y times 5x squared y squared z. Oh no. It looks hard, but here, the cool thing is it's not actually very hard. So, what do y'all think we're going to do?
I think is it like bases are multiplied?
It is. What are we going to do with those numbers on the front? Those coefficients, essentially. The negative 8 and the 5. What's going to happen with those? So, if we use the commutative property, let me try to make things a little bit clearer. We arrange this to negative 8 times 5 times x to the fifth times x squared times y squared times z. What would we do with negative 8 times 5? Yeah, just negative 8 times 5. The numbers in the front, they're just multiplied. They're not like bases multiplied, they're just numbers multiplied. So what's negative 8 times 5? Negative 40. Wow. And then what's x to the fifth times x squared? X to the seventh. That's true. And then what's y times y squared? It is y cubed because there's a little invisible 1 there. That's absolutely right. I was hoping somebody's going to say y squared. That would be an easy mistake to make. But no, it's y cubed.
I almost said y third.
Well, that's accurate. It's just not how we typically say it, but there's nothing wrong with that. What about the z? What's going to happen to him? He's just chilling. He doesn't have any friends. All right. We have one more property. Power of a product. What does the word product mean? Multiplication. Yeah. Okay. So if we have x times y to the a, what do you think happens? It does go to both. So this would be x to the a, y to the a. Easy money. Let's do another example. Let's do that one. I think that's a great idea.
Great idea.
Express the, especially since y'all wigged out about word problems the other day. Oh my gosh, there's words. I have to think too much. It's too scary. Express the area of a square with sides length 3xy squared as a monomial. Monomial, bro. Monomial. Okay. What tools do we need to pull out of our tool belt to solve this problem? What do we need to know about the world to solve this problem?
There are 4 sides to a square.
That's true. There are 4 sides to a square. That's true.
And
They're equal. Now it is. Now it's perfect. Just wait. Next year, you get to use all kinds of symbols and ugly drawings. Geometry is the best. It'll help expand your brain, help you think.
Impossible.
Geometry is the best. Geometry makes you think about stuff.
I'd rather do calculus next year than geometry.
I don't think you know what you're talking about, but calculus is easy if you're good at algebra. So, let's stay the course. Okay, great. That's one knowledge piece. What else would be helpful to know? We've literally only used one word from this whole set of words right now. We've only used the word square, right? There might be some other words that give us some clues and useful ideas and whatever else from this sentence. Monomial, sure. So what does that mean our answer is going to look like? It's going to, no, there's not going to be an equals. Equals is an equation. There's not going to be equals. There's going to be letters in it, right? Maybe numbers, but there's going to be letters in it. There's not going to be addition in it. There's not going to be subtraction in it. There's going to be numbers and letters and those kind of things, right? Easy. So that's great. What else might be useful in this sentence? It has area. So how do we find the area of a square?
Jump back to unit 1.
No, this one should be up here, like off the top of your head. How do you find the area of a rectangle?
I'm only remembering perimeter. I can't.
Length times width. They're both the same. So side times side is what? Side squared. Whoa. So the area of a square equals side squared. That's true. Great. So now what could we do?
We could plug in 3x
We could. So this would equal 3xy squared squared. Now we need to clean that up and make it less ugly, right? So what do we need to do?
Use the power of product.
Use the power of a product, that's true. So 3 squared, x squared, y squared, squared.
I'm not sure that's better.
Well, we're not done yet. What could we do now? This y squared squared, right? That's where they came from, yes? Yeah, I know, but does that make sense where they came from? Yes? Okay, good. Okay, what's 3 squared?
9.
9. X squared. What do we have here?
Y squared.
Right, which property is that?
Power to a power.
Power to a power. So what do we do with those?
No.
It's like, should be in your notes, maybe a page back.
2 plus 2.
Not plus.
Times 2.
In this case, it ends up the same number, but that's like 1 and an infinite. So y to the fourth. There we go. We did it. Okay, so y'all flip in your book to page 393, and I want y'all to do guided practice 4B. It's the very bottom of the page. Express the area of a triangle with a height of 4a and base of 5ab squared as a monomial. Ready, go.
Sorry, example 4 on.
Not example 4, guided practice 4B, like that very bottom thing. Yeah. Yes. Yes.
What example?
No. For the third time at this point, guided practice 4B at the very bottom of the page. Oh. Ah! Oh. Yes, ma'am. Oh no.
Ashley, you can't help Ashley. She's my phone.
The phone was Jack was calling you.
What, right now?
Call him back.
I don't care.
What?
Is area of a triangle height times base times 1/2 or something?
Yeah.
That is it? Okay.
What? You're mumbling. I have no idea what you're saying. Height is, I think, 4a, right?
Height is 4a.
Yeah.
So, height times base, okay. Height times base.
It's at moments like this, I think, I really need to find the time somewhere to develop some sort of like upper elementary / middle school curriculum. Because these are formulas that should be here. It's not your fault if they're not, but they should be here. What?
It could be.
Well, I guess that's maybe true. I guess it could be.
Okay.
You just substitute, buddy. Just substitute. The height is that, the base is that, substitute, simplify. You're mumbling, I can't understand you. 100? There's no way that's right.
Well, it's a half sometimes, which gives you a divide into 2. Actually, it's probably 10. 10
Hush.
Why is this guy on here? It's not that smart.
Quit being dumb and do your math. Good. Well, quit saying dumb things then. You just substitute 4a in for the what doesn't matter, the height, and 5ab as the base. I put them in backwards, but it doesn't matter.
That's
I did it a
That's
little
why Mark
different,
tried
but I
original
got it
one.
right.
What?
That's why Mark tried original one. Because I thought.
Because you'll get the same answer either way, whether you put this one here or this one there, right? Because commutative property. Half times 4 is 2. A times A is A squared. 2 times 5 is 10.
But, okay. But I thought half was on both, they both of them.
It is. But when you multiply numbers, 1/2 times 4 times 5, you can do it one at a time. 2 times 5 is 10. If you would have done it the other way around, 5 times 1/2 is 5 halves times 4, which is still 10.
Or 4 times 5.
Or 4 times 5, which is 20, times a half is still 10. Yep. How did what? The numbers you just multiply. So 1/2 times 4 times 5, which is 10. And A times A is A squared. Does that make sense? Good. Good questions, good things. Great. Let's do another example. Yeah, we got time for one more. And then we're going to get our homework. Let's simplify a big ugliness. Okay. Simplify this thing. What would we do first? Sure. Kind of. I mean, exponents, kind of.
The 2 into the 3 into the A and B and the 1.
This one, this 3 here, is that what you're saying? Okay, that's fine. We can do that. So what is 1/2 cubed? One half cubed. We cubed the top and the bottom. So what's 1 cubed? It is 1/8. What is 1 cubed? What is 1 times 1 times 1? 1, thank you. What is 2 cubed? 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. So 1/8. And this we've got a power to a power, so A squared cubed. What do we do when we have a power to a power? Multiply them. So 2 times 3 is what? 6. And then we've got another power to a power, so B squared cubed is going to be B to the what? 6. Oh my gosh, quit lying. All right, so when we're doing this, we do it from the inside out, right? So we got to square all of this, right? So we got to, the squared gets applied to both. So what's -4 squared? Everybody on your calculator push -16 times -16. Excuse me, -4 times -4. Or you could just tell me by the rules what it's going to end up being. +16, right? And then B to the first squared is going to be what? Yeah, if there's nothing there, it's invisible. 1, right? We've got a power to a power. What do we do with those? Multiply them. What's 1 times 2? 2. B squared squared. Now what? Now what?
Square 16b squared.
That's right. And just bring this guy down. What's 16 squared? 256. And then what's b squared squared? Fourth. There you go. B to the fourth. Now what do we do? What do we do with that 1/8 and that 256? Well, not really distribute, right? There's no plus. It's just multiplication, right? This is basically just saying like this. It's just, these parentheses are being used like that. Same idea, right? So what's we do with 1/8 and the 256? Multiply them. What's 1/8 times 256? Sometime this century would be great. Did you say whatever? 256 divided by 8, enter, is really all you got to push, right? 32. What do we do with the a to the 6th? Just stick him there. What do we do with the b to the 6th? Not quite. Look again. We do. We've got like bases multiplied. So what do we do with the exponents? Add them. So we end up with b to the what? The 10th. Your homework. Nope, you chose to accept it. Already chose. Is on page 395. And I want you to do numbers. 22 through 60, evens.
Okay.
98.5% of those are not hard. Some of them are a little bit tedious, but not that bad. Do the geometry looking ones. Don't chicken out. Look up the formula for volume of a thing if you don't know it in your head. Try them. Come with something tried. Goodbye, chitlins.
Bye.
See you Thursday.